really happy day today because you get to listen to me talk about some math, so I know it's got to be a good day. And we're going to talk about angle, angle, side, 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 and side, angle, side, triangle similarity. What could get more exciting to this? I do not know. Your learning target is I can prove and solve problems of similar triangles using AA, SSS, and SAS. We're just doing a little bit more practice on this. So we're just going to do a couple of examples here, and example 1 says we need to explain why triangle ABE is similar to triangle ACD and then find line CD. Okay, so it kind of combines what we talked about yesterday a little bit. And what we see here is we've got triangle ABE is this smaller triangle, and triangle ACD is part of ABE, but it also includes a little extra little portion of it too, okay? And so we first have to take a look, why are those two triangles similar? And the first thing we could say about this, the first reason why we could say those two triangles are similar is because they share this A, angle A right here, okay? So angle BAE is congruent to angle CAD. Okay, and we know that because that is the exact same angle, which, remember, same things, you have the same line, same angle. It's the reflex property of congruency. Okay. The other thing we can see about this shape here is that C and B, those two angles, are both right angles, which means they have to be congruent as well. So angle ABE, angle AB, is congruent to angle ACD. And that's because of the right angle theorem. Right angle theorem just states that when you have two angles that are right angles, they have to be congruent. Okay, so now we can actually prove that these two triangles are similar because we know two angles are congruent. And remember, that would be triangle ABE, triangle AB, is similar then to triangle ACD by AA similarity, right? Angle, angle. If we know two angles of a triangle, then we know that the two triangles are going to be similar. Okay, so that's the first part of the question, is explaining why the two triangles are similar. And now we have to actually find what the length of side CD is. Okay, so we know the triangles are similar. We've already proven that. Now we have to set up a proportion that'll tell us how we know that those two triangles are similar. Okay, so let's go ahead and write some corresponding parts here. We know that line AB of this little triangle is corresponding to AC of the larger triangle, and that should be equal to line BE of this smaller triangle over line CD of the bigger triangle. Remember, the numerators are all the smaller triangle, the denominators are all the bigger triangle. That has to stay consistent. Okay, so let's go ahead and set in some numbers here. Line AB is 9 units, and line AC is 9 units plus the 3 units, which we can just combine to make 12, right? Skip a little step right here. Line BE is 5 units. And then finally, line CD is the one that we do not know. That is X units. Okay, so we've now set up this proportion that all we have to do is solve for X using the cross multiply rule, or the golf club rule, like I like to call it. 9 times X is 9X. Set that equal to 12 times 5, which we know 12 times 5 is just 60. So 9X is equal to 60. Divide by 9 on both sides, and we end up seeing that X is equal to 60 divided by 9. But if you're like me and you don't know what 60 divided by 9 is off the top of your head, you have to divide it and you get 6.7 if we round it. 6.7 units. So what that means then is that line CD is equal to 6.7 units. There we go. This second example is going to be the same type of deal, and you can see that this photo shows a gable roof. Okay, we know that AC, line AC here at the bottom here, is parallel to line FG. Those are parallel. And we need to use similar triangles to prove that the whole big triangle ABC is similar to triangle FBG. And then once we do that, we need to find out the length of line BA to the nearest tenth of a foot. All right, so first things first, let's go ahead and we got to show that we know these two triangles are going to be similar. So let's write some statements here. We know that the two triangles share a common angle, right? We know that angle ABC is congruent to triangle FBG. And we know this because, again, that's the reflex property of congruency. Okay, we know ABE and FBG are going to be the same because it's the same exact angle. Okay, the second thing we can also say is we know that angle A is going to be congruent to angle F. And the reason why we know that is because these are parallel lines. That line cuts through both parallel lines. We're talking about a transversal. Those are corresponding angles, and corresponding angles are congruent. So angle BAC has to be congruent to angle BFG because of corresponding angles. Because of corresponding angles, okay? So now we've just proven that two angles are similar, so we can write that similarity statement now, that triangle ABC is similar to triangle FBG, and we know that because of angle-angle similarity. We've proven that two angles are similar, so the two triangles are similar. And so now we can take that next step and try to figure out what the length of BA is. Okay, so let's first write some similarity or corresponding parts. We're going to do the same little thing, set up a proportion. And we know in this little triangle that line BF is corresponding to the whole big thing, line BA. And I'm using this side in particular because I know I'm trying to figure out what the length of BA is, right? And we also know that line FG is corresponding to line AC, that big long line at the bottom. I'm using that proportion here because that is information that we do know. We do know the distances of those. Okay, so let's go ahead and plug in some information here. BF, we don't know what BF is, so let's go ahead and call that X. BA, we actually don't know what BA is, except that we do know that A to F is 17 feet, and we already identified BF to be X feet, so we can say that BA is 17 plus X, and set that equal to FG, which is 6.5 feet, over AC, which is 24 feet. Okay, now it's just using our golf club rule again. We're going to build our golf clubs, and we're going to multiply and set those equal to each other. So 24 times X is 24X. And set that equal to 6.5, sorry, times 17 plus X. Okay, so we see we have a little step to do before we do anything else. Is we've got to distribute this 6.5 into the parentheses there. And 6.5 times 17, I don't know what that is, so I'm going to go ahead and use my friend. 6.5 times 17, that gives us 110.5. So 24x is equal to 110.5 plus 6.5 times x, which is just 6.5x. Okay, now we're trying to get x by itself, and so we've got variables on both sides of the equation. We need to get them on the same side of the equation, so we're going to subtract 6.5x from both sides. And 24 minus 6.5, 24 minus 6 is 18, plus another half is 17.5x is equal to 110.5. And finally, just this last step, I'm going to move this down a little bit, is to get rid of the 17.5 to figure out what x really is. So we have to divide by 17.5. We end up seeing x is equal to, don't know that, so 110 23.5 divided by 17.5 is 6.3 if we round it. That means that x is equal to 6.3. Okay, we're not quite done yet, because remember, we're trying to find the length of BA, line BA, and BA was 17 plus x, okay? So we had line BA is equal to 17 plus x, and so we have to plug this information into x here, so 17 plus 6.3, which means that line BA has to be equal to 17 plus 6 is 23.3. And we know that's going to be feet because we've been talking about feet this entire time. So line BA is equal to 23.3 feet. That's how you solve those types of problems. It's a kind of a combination of the last unit. Hope you enjoyed it.